Our final presentation for today is Giselle Bonilla-Ortiz. She's a system security engineer at Raytheon Missiles and Defense in Tucson, Arizona. Has over 13 years of experience in software and system engineering, cryptographic key management, and applications in secure processing solutions architecture. In 2018, she began her doctoral studies in system engineering at Stevens Institute of Technology. Her topic of research is system security engineering for modular open systems. And so she is currently a SERC Fellow, and her presentation is identifying security patterns for modular open systems. Take it away, Giselle.
All right, thank you, Tom. Just wanted to confirm you can see my slides and I'm good to go.
I can see them.
Perfect. Good afternoon, everyone. I also wanted to give a shout out to my advisor, Dr. Dinesh Verma. Hi, Dinesh. I think you're here looking at this session. No pressure for me. So like Tom said, today I'm going to be talking about identifying security patterns for modular open systems. Okay, so an agenda of what I'm going to go through. I'm going to give a quick introduction and sort of like the scope of this particular part of the research I'm working on, and go through the research questions that are building for this topic. I'm going to go through the benefits and properties of modular open systems approach, and then use those established benefits and properties to start showing how we can enhance the security of MOSA systems with those benefits and those principles. I'm going to talk about the benefits to security modular open systems, and then also use those properties of MOSA as to show what sort of security challenge those properties could have on these type of systems. I'm going to talk a little bit about how we could potentially leverage the security challenges from CyberPhysical Systems into MOSA type systems. And we're going to look a little bit at what some existing modular open standards have done, and what are those security lessons learned. I'll conclude and then show you my references. Okay, so introduction. So modular open systems approach, it's the Department of Defense method to designing systems that are composable and that follow open standard. And this is with the purpose, or one of the purposes is so they can be acquired from independent vendors, parts of those systems. So equally as important is the DoD's desire to mitigate the risks of losing critical program information and to protect from potential cybersecurity attacks. So what I'm trying to do with this research is to try to start understanding the attack vectors on modular open systems. And once we start understanding those, try exploring security patterns to mitigate those threats. So the topics that I'm going to talk about today are actually part of a systematic literature review that I'm in the process of doing. And really the purpose of that is that I wanted to establish the knowledge base available to execute system security engineering on modular open systems. So have people thought about it? What sort of challenges they think they will be facing or have faced? And what sort of things they've been looking at. So I started with some research questions. The initial research question, big one, is how do we build a modular open system without compromising its security posture? And what I mean by that is if we were to modularize a system that would otherwise be a closed system and not modular in the same way, is are we actually compromising the security of it by adding the properties of a MOSA system? So the research sub-questions to that are what properties of modular open systems can potentially enhance security? And also on the flip side, which ones can potentially compromise security? What are the attack vectors that threaten modular open systems? And what security patterns we can apply to those modular open systems to mitigate the threats? And also try to answer the question if we can apply security patterns from other similar concepts, from other systems that are by their nature also open and modular, like CyberPhysical Systems or even System of Systems. If we can apply those security patterns to MOSA, can we reduce the risk of threats and vulnerabilities? So on the next slide, what I want to talk about is the benefits and properties of MOSA. And for those of us that are familiar already with modular open systems and why the Department of Defense wants to go this route for their acquisition systems, some of these may seem very familiar to you. I'll also point out here that because this is from a literature review, throughout the presentation, you're going to see where I'm pulling some of the information with a complete reference list at the end. So taking a look at those benefits and properties, if we establish MOSA, we might be able to improve agility of production for systems, cost avoidance savings, and savings, interoperability of the systems. We can help with rapid technology refresh as well when we modularize systems. It can help with efficient logistics and maintenance strategies as well. The components of the systems become adaptable, become reusable because they're following an open consensus-based standards. So we can reuse them across systems, across weapon system, and they can also evolve independently. All they need to do is follow a certain set of rules and standards to be able to be integrated into a system, but they can evolve independently as long as those requirements are being met. Now on the next slide, enhancing security with MOSA principles. So if we take some of the properties from the previous slide, such as rapid technology refresh, interoperability, the reusability and adaptability of the components, using the open standards, and the independent evolution of modules. So if we start thinking about that from the point of view of security, then we realize that we can rapidly reconfigure security components. If we can start developing security, whether it's hardware or software components for our system that that follow modular open standards, then we can reconfigure them quickly and use that as a means to respond to evolving threats. So cybersecurity threats are evolving daily, so this can aid in being able to keep up with that. It helps with the flexible upgrade of compromised components. So if something in a modular system has already been attacked, it's been compromised, it's been lost in some way, if we have a good process or system into how we can upgrade those components, then that does help with our security posture. And on the next slide, so if we take that to heart, if we take those benefits to the properties of MOSA and we do secure modular open systems, so something we need to keep in mind is both MOSA and SSC as separate entities, they have well understood benefits as to why we want to do them, right? So like I mentioned before, benefits of MOSA are enhanced competition, innovation, cost savings and avoidance, improve interoperability amongst systems and components. And the benefits of SSC is threat mitigation, addressing system loss scenarios, and protecting the critical program information that's important to enhance warfighter advantage. So if we take a look at the picture up there in the upper right corner, it's the same theme, right? The benefits to make sure we understand the security of a modular open system is what will allow us to know what modules can be upgraded quickly if they are compromised, or if technology has advanced, right? Technology can sometimes advance faster than we can upgrade our systems. So this is something that will help for that. Security and critical program information, like I mentioned, while at the same time still maintaining operabilities with other components in the system. And then design for authenticity is something very important that we need to think about. If we go to the more general property of a modular open system of it's meant to be plug and play, designing for modules that need to be authentic to live in that system, to be integrated into that system is important. So now that we've talked about the benefits, We've talked about how the properties of MOSA can help the security posture. We've talked about the benefits of following a process that incorporates security into MOSA. So if we start looking at the properties of MOSA from the other end, and how could they potentially lower the security posture of a system? So interoperability is one of those properties, right? Some of the things we need to think about is module trustworthiness. Where is it coming from? Once it's integrated into the system, what are we actually giving it access to? And is the access only what it's required for that module to meet the requirements of the system? If something does become unsecure or gets compromised, how are we constraining it? Is the system smart enough to be able to constrain something that it knows or thinks it may be bad at a certain point? And also malicious data flow. If we think of these modules as black boxes where they meet the requirements and they meet the open standards, is that module, does it have some bad intents in producing malicious data into the overall system? That's sort of what I'm showing with the cartoon there. Is if we were to swap out module 1 with module 1A, and module 1A captures all of the requirements for the open standards and for the system, but what if it's compromised somehow? What if there's malware in it? Some of the things we need to think about. And in a similar way, the security challenges of something that's adaptable and reusable, it's very similar to interoperability and how we look at it. So again, the module provenance and understanding the supply chain risk of those modules, and if malware could come in those modules that we're adding into the system if we're integrating it. Compromised modules as well. A lot of the issues with security may actually be emergent in the system after the integration is actually done. So if we look at just the individual posture of security for each component, we may not be able to see the whole picture. So we need to understand how the integration of the different modules will actually affect the overall security posture of the system. And then finally, use of open consensus-based standards. So something that I've been asked about before is that we talk about open standards and we have a misinterpretation that open source suddenly means vulnerable. And that's really not the case. But there are a few things we need to think about with the wide range of open standards that are available to us to integrate into our systems. So we need to think about what are requirements for data confidentiality, data integrity, and if those supported security protocols are actually in the standard. So this is why we need to think about security all the way up front when we're designing a system, because what if we select a open standard whose security protocols don't actually meet the requirements for our systems? So it's something very important to think about. What if we need to add the security on top of the open standard that we are using for this MOSA system, so that adds to this cost and the schedule of the system because it's not actually coming with the standard. And then on the next slide, just a few notes on how we could potentially leverage ideas from the security challenges of cyber-physical systems. So let's talk about the building blocks of cyber-physical systems versus MOSA, right? Both will probably use a multitude of commercial off-the-shelf devices, and some may be proprietary. We may not be able to open everything, right? But every component could contribute to an attack, every component that you add to the system. But more importantly, also, it can add to the system while it's integrated. So it's not, like I mentioned earlier, it's something emergent that you may not necessarily see by only studying the particular security posture of a component. There's a lot of stakeholders potentially that are going to be involved. So this can lead to uncoordinated changes of modules. And how do we aid in that change management? How do we maintain the security posture of the whole system and can track everything that is going in? So standard interfaces, that helps us out because we can use both new components, we can use legacy components and COTS, but the vulnerabilities really are, again, at that boundary of integration. So we have to do that integration with security in mind to minimize the risk. What potential risks are we bringing into our system by using older components or using COTS that may not necessarily have the security posture that we need? And then finally, some lessons learned from looking at existing and emerging MOSA standards. So the first point I want to make is it's critical to perform security use cases and needs analysis early and upfront. I think we all know that security is not something that we should bolt in at the end, especially with a system that could provide such an emergence of risks and vulnerabilities that we may not necessarily see at the beginning. And it's important to understand common threat vectors. So using also as an example, one I've looked at is the sensor open system architecture. They already have developed common security reference architectures that they are going to be using in their system. So why reinvent the wheel, right? If we can understand the unique properties of each open modular standard, we can see what we can leverage and reuse across standards as well. Another thing we need to think about is modularizing security patterns when possible. When we standardize security components, when we standardize those algorithms, it goes back to the point of being able to quickly upgrade them and refresh them if we need to. And the second sub-bullet there about usable security components is very important. We can create the most secure component and therefore the most secure system in the world, but then not be able to use it. So as we go through the process, through the thought process of what we are modularizing, is also important to think about the usability of them. Plan for a scalable configuration and a phased deployment of security. We may not have all the answers up front at all. So we need to understand how we are going to phase in maybe new technology of security during the life cycle of our system. And that goes back to modularizing those security patterns when possible, is that they not only can we upgrade them quickly once the system has been deployed, but also during our process of development and production of the system. If new security technologies come along that meet our requirements and can be integrated in, we can do that a lot easier if we've standardized those security modules. And similar with that last bullet, enable for upgradable and extensible security components. For evolving requirements, security components are not necessarily going to meet the requirements of all the years a system needs to be deployed. So we need to be able to understand how we are creating those components in an upgradable way. And in conclusion, understanding the threat vectors for modular open systems and leveraging cyber-physical systems, security concerns may help provide inputs for creating those reference architectures for modular open system, and understanding what sort of composable security requirements or patterns we can make. Like I mentioned earlier, so this research, the literature review specifically, is in progress. So what I've presented here today is what I had at the time of right when my presentation needed to be ready for publication. So if anybody is interested in learning more about where I've progressed in the research so far, please feel free to send me a message and we can discuss as well. On this next slide, for those that would like to take a look, it's really just a handful of references that I've used specifically for this presentation. So feel free to take a look there. And that's me. I'm happy to take any questions now, so I can go back to my conclusion page, if that makes it easier. Thank you.
Great, Giselle. Looks like we've got questions out there so far. Joe Bradley asked, does how does a DevSecOps fit into or with MOSA?
Oh man. So Joseph, you're asking about one of the few things that I haven't looked at yet. I think a lot of these concepts actually work in parallel, right? You can certainly use DevSecOps as your understanding the requirements for integrating and designing your modular open systems. So they're not necessarily divergent in it, as you can use your DevSecOps for the processes for developing MOSA and for securing MOSA. I hope that helps, Joseph.
Next question came from Mark Winstead. He asks, off of slide 10, does open/consensus somehow mean best, or does majority truly rule?
Oh, so Mark, a good question. What I mean by that is there's several consortiums of industry and government that work on standards for different types of systems. So like I mentioned earlier in one of my slides, the SOSA, the Sensor Open System Architecture. So what that means by that consensus is that there's that group from industry and from the government that work on what the requirements are for that particular standard and design the architecture that goes with it. Now, in terms of majority truly rule is, we're never going to have one standard, right? I think we're going to have a multitude of modular open standards that are going to be applicable to different types of systems. So that's an analysis that needs to be made by program managers and engineers into which one would fit best.
Okay, and a third question from Beth Wilson. I enjoyed your SSS 2020 paper and like the focus on the system boundary. Can you mention the MOSA stakeholder relationships and how this influenced secure MOSA requirements?
Yes, Beth. Hi. So thank you. So for context, in the paper for SSS 2020, I present what the boundary of a MOSA system looks like, and it was looking particularly from the acquisition point of view and the stakeholders of that system. Thinking back on what that particular stakeholder map was, it was trying to show how the requirements would actually flow from the government into the contractors. So that would influence requirements usually specific for certain types of systems, and then knowing what those requirements are, then the acquisition engineers and the systems engineers and the security engineers would have to figure out then what specific open standards would meet those requirements. Does that help answer your question, Beth? Or if you have a follow-up, I can certainly help out there as well.
Did not see a follow-up yet. I have a question too. You mentioned both patterns and modules in this space, and so obviously modular and open is one type of pattern, but when you talk about security patterns, they tend to be behavioral patterns that run across multiple parts of the system. Can you talk about what you're finding in that space?
So when I use the word module, and I know that can be a little bit loaded depending on the context that we're discussing, I'm thinking more of from a physical perspective, a hardware module that belongs to a system, right? So the security patterns, it's specifically what you said, exactly what you said is a security pattern is a behavioral thing that can be used across the modules of that MOSA system. It could potentially be unique to a module, but that's not necessarily the case we want to go with if we want to make these patterns more composable to be used across the system. Does that help, Tom?
Yeah, yes. You answered my question. Thank you.